Hi students, this is Kishore, faculty in ECE department, DBS IT Kavali. In today's class, we are going to discuss about another alternate gate circuit, that is special circuit for special applications, that is nothing but CMOS Domino logic. So already in the last class, already we discussed dynamic CMOS logic. So it is the dynamic CMOS logic. So we are having some disadvantage. That means for a longer time period, it may consist the same logic for the same. If you are changing the inputs, that will maintain the same logic. So to overcome that disadvantage, we are going for CMOS Domino logic. So this CMOS Domino logic is Domino CMOS logics, slightly modified version of the dynamic CMOS logic circuit. The addition of the inverter solves the problem of cascading of dynamic CMOS logic circuits. So here we are adding an inverter circuit. So whenever we are observing CMOS dynamic and domino logic, so this entire that means recharge transistor and evaluation transistor NMOS logic is same for both the dynamic and domino logic. So here the domino we are adding an extra inverter for this design. So because so to change a fast response for applying input whenever we are adding the inverter at the output of the circuit. So whenever we are adding this inverter, we are having different advantages and the disadvantages. Those are nothing but the smaller area compared to the conventional CMOS logic. So whenever we are representing this type of design, so it may require the smaller area compared to CMOS logic. And in case of the CMOS logic, we are having parasitic capacitances, but here the parasitic capacitance are smaller, so that the higher operating speeds are possible. So the operating speed of the domino logic is very high compared with conventional CMOS logic. And next one is the non-inverting structures are possible because of the presenting inverting buffer. So at the output of this circuit, we are adding an inverting configuration. So due to this, the non-inverting, that means the non-complemented function, that is y is equal to a plus b, or y is equal to ab plus cd, or y is equal to ac plus ba, like this. So we have to perform different non-inverting functionalities by using domino logic. But here one of the disadvantages is there, the charge distribution. That means the charge will be distributed from one transistor to one point to another point, or one configuration to another configuration is difficult wherever the logic may exist more number of elements. So that is only one of the disadvantages. So here coming to the operation of this circuit, the CMOS domino logic is similar as dynamic logic. So here, so it may consist both the pre-charge and the evaluation transistor. So here also we are having the two cases. One is the case one is, so if the pi is equal to 0, so at that case, so it will be closed switch. That means it will be on switch. So from this path, it will establish a conducting path from VDD to this point. So the current will flow from this direction to from VDD to up to this point. And the same logic will be applied to evaluation transistor 0. So because of the 0, the low voltage, so it will be off switch. That means it is an open switch, there will be no path. And the same, that VDD voltage will be given to inverter. So it performs a general CMOS inverter. If the input is high, so for the high case, So this will be, that will be, it will be inverting, one will be inverting 0, 0, and this will be off condition, and one for the one NMOS transistor will be on, and the output is equal to 0. Output is equal to 0. That means so whenever we are applying the 0 and the output is 1, but we get the 0. So if the 0, the inverting input is 0, and we get the 1 as the output. So based on that, we have to perform the inverting and the non-inverting properties by using the CMOS Domino logic. CMOS Domino. And next, case 2 is if the input is high, if the input is 1, for that input, this will be off switch. So it acts as a open switch, and the PMOS transistor will be in off switch, and it will be on. NMOS transistor will be on. So if the switch is on, the path will be, that is the ground will be connected to the inverter. That means ground connected is, the input is 0. If the input is 0, so this transistor PMOS transistor is on, and the NMOS transistor is off, and the output is VDD, because the PMOS will be acts like as a closed switch. Then at the time, so if the input is 0, output is high, and the input is low and the output is high. So vice versa, the logic will be reversed. If the input is high, output is low. If the input is low, output is high. The inverting operation will be implemented by using the CMOS Domino logic, and that same thing will be implemented in different type of logic functionality. Either it may be a combinational functionality or a sequential functionality. So here I have one of the example. So I am implementing a CMOS inverter by using CMOS Domino logic. CMOS inverter. So here that inverter, the inverting functionality is nothing but y is equal to a bar. Y is equal to a bar. That means I have to implement this y is equal to a bar. So that is equal to non-inverting functionality, y is equal to a. So that will be implemented by using CMOS Domino logic. That means whenever we are observing CMOS Domino, we are having the pre-charge transistor and the evaluation transistor. In between we have a NMOS logic. So the same. So in this design also we are having the pre-charge transistor and evaluation transistor. In between, so we have to implement whatever the logic. That means logic functionality we are developing that will be placed under NMOS logic. So that means how many variables present in the given logic functionality. So that given logic functionality we are having only one variable. So that's why I designed or I placed one NMOS transistor between the pre-charge transistor and evaluation transistor. And at the output of this NMOS logic will be followed by a CMOS inverter. That is the combination of both PMOS and NMOS, and at finally we get the output. So here the operation of the circuit will be explained by using this truth table. So that is pi is equal to 0. So whenever if the pi is equal to 0, so at that condition, so we are applying a is also 0. So for this case, so here the PMOS input is also 0 and NMOS input is also 0. For the PMOS transistor, if the 0, that will be inverting 1, that means so the P-type transistor will be on, that means closed switch, it will be acts like as a closed switch, and the VDD voltage will follows through this transistor, that is a pre-charge transistor, and A is equal to 0, and for the evaluation transistor also 0. So 0 means it will be both the transistors are off. Off means it will be the entire, that means A and evaluation will be terminated from the circuit. That is there is no ground path for this case. That means the VDD is nothing but high voltage 1, one will be followed to the inverter. So for the, if the one input is 1, for that case NMOS transistor will be in on condition, and for this PMOS transistor will be in off condition. On means it will be connected to 0 and we get the 0 because so here whatever the pi will be followed, that means the phi will takes place the entire operation. That means if the non-inverting or inverting functionalities, if the phi is equal to 0, we get the same 0. So if the A is 0 and Y is 0, that means whatever the pi will takes place, the entire circuit will be under that condition, that is pre-charge condition. So same again, next case is also if the pi is equal to 0 and we change the 1, even though it will be in on condition, the NMOS transistor will be in off condition because the pi is equal to 0. So for that case, same again the input, the VDD voltage will follow the inverter and we get the output is 0. Even though if the pi is equal to whatever the pi will be applied, so that will controls or that will maintains the entire operation of the circuit. Controls the entire operation of the circuit. And next case, if the pi is equal, changes the 1 and the output is also changes. That means the output follows the pi value. That means the entire operation will be depends on pi value. So based on that, we have to get the inverting functionalities. So here the A is, if the 0, we apply the 0, 1 and we apply 1, 0. So based on that, the output will follows the pi value. That means controlling value to get a perfect result by using CMOS Domino logic. And again we have to, I will explain clearly how to design another circuit by using different logic functionality. Another example for that, for this domino logic is, that is y is equal to a into b plus c whole bar. So in this example, we are having 3 variables, that is a into b plus variable, and the same thing will be implemented by using domino CMOS logic. So first I have to write the pre-charge transistor with p-type transistor. So p-type, so that will be use the input pi value and applying VDD voltage and applying VDD voltage. So here B element and the C element are OR function and the A is AND function. So B and C, if we are OR, so that will be follows parallel functionality. So and N is series. That means I have to take one N-type transistor with C, A variable, and the B and C are parallel. In parallel combination, we have the condition how to draw, we have to maintain the series and the parallel connection. So here B or C are functionality, we have to parallelly connected, and that combination we AND with multiplied with A, so that's why we have to connected series. Again I have to take a connection for the evaluation mode, so that will be again series with entire setup. So finally that will be connected to ground. So here in between evaluation and the pre-charge, wherever the NMOS logic is present, so here we have to connect a inverter, a CMOS inverter, that is nothing but it consists of both the PMOS transistor PMOS transistor and the NMOS transistor. So here the PMOS we have to connect the VDD supply voltage, for the NMOS ground connection, and finally you get the VO. So here this entire setup will have the NMOS logic. NMOS logic. So this is, in this way we have to design any type of logic functionality or logic expression. So whenever we are writing the truth table for this design, so we will verify the input and output by applying the cases, case 1 and the case 2. So in this way we have to design different logic circuits. So thank you for watching. Please subscribe DBS Talks. Hi students, this is Kishore, faculty in ECE department, DBS IT, Kavali. So in today's class we are going to discuss about subsystem design. So already we are designed so many systems by using different logic functionalities or logic methodologies. Those are nothing but NMOS circuits and PMOS circuits and the CMOS circuits. So in today's section, so we have to discuss different subsystem designs. Those are nothing, first subsystem is nothing but pseudo NMOS logic, and the next one is dynamic CMOS logic, and another one is domino CMOS logic, and the final one is clocked C-square MOS logic. So already, so whatever the logic functionality, so we know that the logic functionality may consist mainly two type of operations. Those are nothing but AND operation, that is multiplication, and the next one is OR operation, so that is nothing but addition operation. So whatever the logic function, so that will be implemented by different systems, that is whether it may be implemented as a PMOS circuit or another NMOS circuit or CMOS circuit. So already we seen we designed different circuits under stick diagrams and the layouts. So in especially in that in pseudo NMOS logic, so before going to pseudo NMOS logic, so I have to remember the operation of the CMOS inverter. So in this CMOS inverter may consist two type of transistor. One is the P-type transistor and the N-type transistor, and at the top of the P-type transistor, for the pull-up transistor, so it will be connected to power supply. So that is name it as drain voltage for the P-type transistor, and the ground, the substrate will be grounded for the NMOS, that is pull down transistor. So whenever we connected together two transistors, so it will be acts as a inverter. So that means, so here at the gate terminals of the both the transistor, so we have to apply Vin voltage, and in between the source and the drain terminal of the N-type transistor, we have to take output of the design. So here for example consider, so coming to the operation, so here I am applying 0 to Vin voltage, 0 voltage. So for that case, so here the input voltage for the PMOS transistor is 0 and the input voltage for NMOS transistor is 0. So here for the 0, here we having the inverting operation. So due to this bubbling contact, that means the channel or the path between the gate terminal and the drain source terminal will be closed, then it will be established a connecting path in between the P-type transistor. So this connecting path, due to this connecting path, this transistor will be on. So on means it will be connected to VDD, then the output voltage at the time is equal to VDD. The Vout is equal to the VDD. So because so we applied the 0 voltage, but we get the at the output of this design is VDD voltage. So here the NMOS transistor, So for that same the case, it is 0 and it will be connected. 0 means it will be open switch. So this is a closed switch and this will be open switch. So based on this factor, the output voltage will be VDD. So next case 2, second case, whenever we apply input is 1 voltage. So at the time this will be this will get the 0 volts and this will be open switch opened in between VDD to, that is the drain terminal to source terminal, and this transistor will be on 1. So this will be on. So at that case, this will be on means it will be connected to 0 volts. So at the time Vout is equal to 0. So here the case is under case 1, whenever we apply the 0 voltage, we get high voltage, that means 0, 1, and whenever we applied the high voltage as the input voltage for the case 2, high voltage, so at the time we get the 0 volt. So because of on and operation of the P-type and the N-type transistor. That means whatever the logic function we have to design under the CMOS technology. So we have to use both the P-type and the N-type transistor. So whenever we are using both the P-type and the N-type transistor, so that we are having the following drawbacks. Those are nothing but increased area and increased capacitance, and third one is greater or more delay, and the fourth one is circuit complexity. So this circuit complexity increases for the reasons designers developed alternate gate circuits that can be used to supplement the complementary type circuit. So these forms are intended to replace CMOS, but rather than to be used in special applications for special purposes. So in pseudo NMOS logic, the NMOS transistor is driven by the input voltage, while the gate of the P-type transistor is connected to ground or substrate, and it acts as an active load for the NMOS transistor. So the advantages are, so it uses less number of transistors. Compared to the CMOS transistor, and the area and delay gets reduced as it requires less number of transistors. So whenever we are comparing CMOS and the pseudo NMOS logic, so we have to implement any logic that may require both the P-type and the N-type transistor. But here pseudo NMOS logic, so we have to implement only the NMOS logic. So due to the less number of transistors, it may operates under low power, or it may consume low power dissipation the entire circuit. These are the advantages. So we in this also we are having the disadvantage. So that means whenever we are implementing this type of design under layout, so that will create some problems in layout section. So here now the pseudo NMOS logic, coming to the operation of the pseudo NMOS logic is, so here the pseudo NMOS logic may consist P-type transistor and the NMOS logic. That means whatever the logic, either it may be the logic functionality may consist AND operation or OR operation, whatever the logic elements within the logic function, so that should be implemented only by using the NMOS transistor only. So we need not to take a P-type transistor within the design. So only whatever the logic function we are implementing, so that will be implemented by using only NMOS transistor. So here the QP will be acts like as a load in between the NMOS logic and the VDD. So that is the main difference between pseudo NMOS logic and CMOS inverter. So here, so by using this setup also, we have to implement any logic design or logic functionality. So for example, consider if you want to construct a inverter by using the pseudo NMOS logic. So simply here I have to add one N-type transistor to works like as a inverter. Vin. So this is only the modification we have to do, or we have to perform the NMOS inverter compared with the CMOS inverter. So here only we have to give the input to only NMOS transistor, but here we have to give the input to both the transistors. So here one end of the P-type transistor will be grounded. So whatever the operation or whatever the thing will be happened within the CMOS inverter, so the same thing will be happened by using this setup also. But the main difference is it may consumes high power and it may consumes low power. That is the main difference by using pseudo NMOS. So for example, coming to the operation, so if we are applying Vin as 0, so for that time, so it will be off switch. Off switch means it creates a open junction between the ground to this one. So here always this end is 0, so it will be always in on condition. So on means so it will be acts like as a closed switch, and the VDD voltage come out through V out terminal. So that is nothing but VDD voltage. So that is logic high. That means whenever we are applying the 0 voltage, so we get high logic. That means inverting operation. Now consider and second case 2. Whenever we given one as the input, so at that condition, so it will be closed switch. That means on switch, the path will be exist. That means the current direction will be exist from one end to another end. So during this case, so this will be also on and this will be also on. So at the time we will get 0. That means entire VDD voltage will be pulled down to the ground voltage. So at the time we will get the output is equal to 0. That will happen when the input voltage is high. That means it will perform the inverting. So whenever we give the low voltage, so the output will be high, and whenever we give the high input voltage, the output will be low. So it performs the inverting operation. So this is about pseudo NMOS logic, and we also implement different logic functionalities. So that is nothing but 2 input NOR gate and y is equal to AB plus CD whole bar and y is equal to ADP plus C whole bar. So to perform these logic functionalities, we have to remember 2 conditions. That is nothing but how to connect. For example, consider this logic function. So here we are having the 4 variables. In this logic function, we are having 4 variables. So that is A is the 1 variable, B is 1 variable, and C is 1 variable, D is the 1 variable. So here between the A and B we are having the AND operation, and between the C and D we are having the AND operation, and for these 2 we are having the OR operation. So to perform those operations, we have to follow these 2 conditions. So we have to implement the logic wherever the NMOS logic shown in the pseudo NMOS logic. So we have the AND operation. So we have to connect how many variables present within the logic design. So that will be that number of transistors will be connected in series. For example, here we are having the A and B. So AND operation. So A and B will be connected series, and R operation will be parallel. Again C and D will be series. So by following these conditions, so we have to design any type of logic functionality. Thank you for watching, and please subscribe DBS Talks.